Hello, my name is Thomas and today I'll be showing you the process of creating a radial blast ability in Unity through procedural animation that will be able to push nearby objects from the center. The concept derives from my current bachelor project, where one ability of the player will be to create a shockwave around themselves to damage and push enemies away. Through using particle systems in creative ways, this ability will be able to affect a variety of objects around it, such as dust, paper, boxes and the like. For this ability we will need a few things: the code to make the ability function, the source object from which the ability originates, in this case our player, and the affected targets. These can be anything from random objects to enemies. For the visuals we'll need a particle system that can show the player the effect of the ability, as well as a couple of textures that I will show you how to utilize. All the assets used in the video, including the script, will be available in the documented zip delivery file. I have here a scene containing a player character that can't do much more than move around. In the inspector we will add a component to the player. We will add a script and call it Radial Blast. First of all, we will need to declare a public game object, which will be our player. We'll then need a few different floats that will be necessary parameters for our blast. These will be called public float applied force, blast radius, and up force. We will also have a private float called blast time. Use serialized field to edit the float later. In our update method we'll make an if statement for our key input. And within the curly braces we'll have our blast method. Visual Studio will tell us that there aren't any methods with that name, but all we need to do is click on the name and press Alt plus Enter and enter again on our keyboard to have Visual Studio create a private void for us called blast. Delete the line of code generated within the method. The function of the ability itself is actually very simple. It works by using what's called an overlap sphere from the source object in order to find every collider in its vicinity and then apply force to those objects. We declare a vector 3 as the position of our player. We'll call it the blast position, and it will be equals to the player.transform.position. We will then need our sphere collider that will originate from this position and interact with the colliders of the objects around it. Write collider, then object colliders equals physics.overlapSphere. The overlap sphere will use the position that we just declared, and its size will be determined by the blast radius. Using this for each loop, the sphere collider will detect if it has hit any of the colliders of any object in its radius. When it has found these colliders, only then will the sphere collider get the rigid body component of these objects. Making sure that the rigid body component of the object is active with an if statement, we then use the rigid body method known as add explosion force. This is where we will need our previously declared parameters, those being the applied force, the blast position, blast radius, and up force. As you can see, the blast is working, however it seems to lack any impact. This is why we will need another element to our add explosion force method called force mode. Force mode is an enumerator, meaning it holds multiple different properties, and will determine specifically how our method will add force to the surrounding objects. These properties are called force, acceleration, impulse, and velocity change. For this ability we will need to use impulse, which will add an instance of force to the object and use that object's mass. This will allow us to alter an object's mass individually and have it be affected by the blast differently from other objects. Now that we have our blast ability working, we'll move on to adding some visual effects. To do that we'll need to create a particle system. Click on Game Object, Effects, and Particle System. We'll start off by creating a blast ring. Start by changing the start speed of the ring to 0 and start size to 40. Leave the rest of the parameters for now and move down to emission. We don't need the amount of particles the system is currently spawning, so we'll reduce the rate over time to 0 and add a custom burst, and reduce the count to 1. With the blast ring finished, let's add a second particle system. This will be a sphere of energy around the player that we'll call blast sphere. For the basic parameters and emission, we'll mimic the steps we did for the blast ring, but feel free to experiment with the numbers based on what you want the result to look like. We'll make the shape of the effect a sphere, however this will only change how the effect spawns. To get an actual sphere, we'll need to go to, you guessed it, the renderer. We'll first create our next material and call it Matte Blast Sphere, which will need the hexagon texture, as well as having its own shader and renderer mode be the same as the blast ring material. Let's quickly add this material to our renderer, which now just looks like an image. This is because we'll need the renderer mode to be that of a mesh. Unity will have a sphere mesh for us to use by default. Find and select it, and then we'll add the material once we have our sphere. It seems our material is being stretched out and not giving us the result we'd wanted. Though, the texture of the material is made to be tileable, meaning we'll be able to increase the tiling of the material and have it look seamless. Let's change a few more things of the material before we're finished. Let's enable soft particles, which will make the visible top and bottom parts of the sphere have some soft opacity to them. We'll mainly focus on the far fade parameter. We can enable emission for the material and change the color of the albedo and the emission appear as if it's emitting light. Moving back to the particle system itself will adjust the size and color over lifetime just like with the blast ring. However, with the sphere I wanted to shrink into the player before expanding to create an effect of anticipation. We'll complement this effect with the color over lifetime by having the opacity start out at 0, increase as the sphere expands, and then be reduced to 0 again as it slows down its movement. We want our two effects to be played simultaneously, and we'll do so by adding them both to a new empty parent called Blast Effect. You will need to add a particle system to this parent for the effect to play, but we do not need it to have its own effect, so we'll just disable all of its properties. Before we move on to adding the particle system to our ability, I want to show you an alternative to creating materials for your own particle systems. In the case that you're unable to create your own textures, an alternate solution is to use an image that can yield a different yet still desirable result. Using this image of a water texture found online, I'll make a new material, call it Matte Water Sphere, and add it to our Blast Sphere effect. The effect works, but let's add some movement to the material itself to make the effect more interesting. A quick way to do this is to enable texture sheet animation and increase the tiles to 5 by 5. This property is more commonly used for particle system using sprite sheets to animate each particle, a common way to animate fire effects. In addition to the texture sheet animation, we will also have our sphere rotate to add even more movement to the effect. The effect is looking good for what we're working with, however we might encounter another problem when the effect is played in-game. The overwhelming bloom here is caused by an overabundance of particles, 1000 of them in fact. Yes, even though we have adjusted the emission count to 1, we still have to make sure to reduce the max particles to 1 as well. Now the effect should look as intended in-game. Now that we have our particle systems, let's make it possible for us to play them alongside our blast ability. We need to disable play on awake to not have the effect play before we hit the button. To be able to play them, we'll have to go back to our script. All we need to do is create a public particle system, call it blast particles, and then in our blast ability method, type blastparticles.play. The particles will now play when you press the Q button. However, we have a couple of things that we need to change about the script to make it work as intended. I want the ability to have the player stop moving when using it, but we can't do that with the void method. What we'll have to do is first comment out our blast ability in our input by typing 2 dashes in front of the line, and then below that write start coroutine and then blast ability within the parentheses. We'll then make a new type of method called an IEnumerator and cut and paste the lines from our void method. We'll then get the character controller component from our player and make it false. To disable the movement for a specific amount of time, below the line that plays our particle system, we'll write yield return new wait for seconds and have it be based on our blast time float from earlier. At the end of our IEnumerator method, we'll copy the line from the start and enable the character controller again by writing enabled equals true instead. The next thing we need to do is make the ability spawn at the player's location. A simple way to do this is make the transform.position of the blast particles be equals to the transform.position of the player. Quickly before we're done, let's make sure that the player is actually tagged as a player and then restrain our player's rigid body positions and rotation to make sure we don't go flying when using the ability at any point. And there we go. We have our ability to blast away objects with matching visual effects. Thank you for watching.